All right, so today we are going to talk about the methods. Have we seen methods? Yes. In the last 5 chapters we have used quite a few methods, but we wanted to clarify a few things and make sure that we understand how we are using the methods. Okay, so in general, the reason you would use method is you want to break it down into smaller chunks. Okay, so instead of writing a big program which is going to be about yay big, 50 lines long, I can actually break it down into smaller chunks and say, okay, I want to write a method where it gives me a good introduction to the program. You know how sometimes I say make it interactive, make it a good program that you can tell your user what it is all about. So you can probably create a method saying welcome. You know, welcome to my program. This program does such and such things. And just write that method. And then you might also have another method like this, and you say goodbye. And you just say, you know, thank you for using my program. You know, you've been really good. Now, if I write those methods, I can basically take that method and use it at every program. Okay, so that's why I would use methods, so that I can reuse them continuously. So what I'm going to do is, just like the other chapters, I'm going to go point out a few things from the book and then start going over examples with real programs. And I would point out how we are using the methods, and then also refer you back to the book saying, okay, this is what it's talking about, when the book goes over, okay, when we declare a method, it is static and this is what it means. All right. So, and since we used Eclipse last time, I'm going to use NetBeans and start off our NetBeans while it's coming up. Let's look into the objectives over here. So some of the things that we will talk about here would be the library methods. Again, we have already used some library methods that is already written in the Java library, and we just refer to that library, and sometimes we have to bring in that import statement so that we tell the IDE that, okay, this is where you should look for, and then I can use the method. Similarly, I can write my own method. So I say, no, you know, I don't like the method that they wrote, so I want to write my own. Okay, so you can write your own method as well. Now, one thing that you will always hear, that when you read Java documentation, they say Java is a very, very library rich language. Pretty much anything that you want to do, somebody has already thought about it and have written a method for it. Okay, so it is a matter of you looking and seeing where to find those methods. So if you go to the java.doc or Oracle and look for Java documentation or any of the libraries, they would have pages after pages after pages. Okay, so you'll say, okay, this method uses this, or this method, this is what it should be doing. So it has a little description, it tells you exactly how to do it, and then you basically bring that method into your program and use it. Now, this is also where the concept of the method and the argument or the signature comes in. Remember when we talked earlier about the classes and objects, we said you can write methods, or we can repeat methods in the same program. So we call them overloading the method. However, one method has to be, the signature of one method has to be a little different than the other. So you can write a method called, you know, addition, okay, one where it would be void, okay, then you cannot return something. Or you can write a method called addition where it takes 2 parameters versus another method that would actually take 3 parameters. So that way, even though we are calling both of them as addition or add, I can still use the method and the object knows exactly which one to go because it looks at the signature and says, okay, it should take 2 parameters. So when I call this method called add and pass 2 values, it knows to go to that one. And when I pass 3 parameters, it knows to go to the right place. So that's what method overloading would do. And we will also talk a little bit about, once we do create those methods, how can we use them in other classes. Okay, so this is where we will clarify a little more of our static versus non-static. Remember when we started our Java discussion, it says public static void main. I said, okay, let's understand what public means. Let's leave the static part out and then main. Okay, so this is where we are now getting into the static as to what it actually means. And I already referred to you about this software reusability. So you do not want to write this thing over and over again. If you create a welcome message, then you can call it at any point and it's going to do the job for you. All right, now some of the example that you should have seen already is that scanner. Remember, that's a scanner. So this is where I'm actually bringing in the class, instantiating a new object called scanner, input scanner, keyboard scanner, whatever, in saying new scanner, and then I'm going to use that scanner associated with a method called next int, next double, to bring in some values. All right, so methods can also be called from within each other. So this is just a pictorial representation where you say you have one method, which is the boss method, and that boss method can call the worker method. Yes. Yes. Can you hit the light switch at the back? Better? Don't fall asleep. All right, so in this case, you have a method called boss, and then the boss in turn would call worker 1 or worker 2 or worker 3. Now, this one in turn can also call these methods. So it actually can go, and this is really the beauty of the object-oriented language. Once you write them in individual modules, you can basically call them from wherever. Okay, but again, there are certain syntaxes you just have to follow, the syntax rules that you have to follow. And we'll take a look at some of these things in this chapter when we talk about it. So this is where we talk about our static versus non-static. So let's clarify or look over this, and then I'll show you an example. So here we talk about what are my static method. So when we have a static method, it is also called a class method, then I do not need to have an object instantiated with it. Okay, so when we say public static void main, that's a static method. Okay, so I don't need to create a new object out of it. However, when we had created things like account or student, we did only the class, we did the set get methods. Okay, but those methods had to be used with an object because those were not static methods. Okay, so you actually refer to a method as static by indicating that this is a static method. Okay, now when you do use, so what it's telling you is classes often contain convenient static methods to perform common tasks. Okay, for example, and I'll show this example in just a minute, math static is using this method. So I just say the class name dot the method name and the argument, and then it is going to do my job. However, when I use any of the non-static method, then I have to first of all create an object and then associate that object with that non-static method. Okay, and the reason is, remember why we create our objects, or why do we create those classes? We create those classes because we want to create a blueprint. Okay, I don't want to repeat that method over and over again. So when I create those non-static methods, okay, then every time I create an object, it actually associates that non-static method with that object. So it stays with that object. The next time you do it, you don't have to do it again. You just associate again. You create the new object associated with that object. So that way all the objects information are kept separate. Okay, so I don't need to keep on repeating the same thing over and over again. And we'll look at some of the examples as we go along. So here are some of the methods, and this is what I was talking about earlier, that if you go to the Java documentation, it will actually tell you how to write this method. So it says, these are my math class methods. So if I want to use this method, most often I'll have to write my class name, which is going to be math, and then I have to call, or then I have to associate that with my method name. So I would say math.exp. See, it's telling me it's going to take in one argument, right? Whereas there may be somebody else or some other method that may take two arguments. In this case, all of these things have one. So what is this? It's an ABS, or absolute value, and it says, and it gives you an example. If you pass this a value over here, of course you can see that this is a double value or a float value that you can pass. Then it's going to change it from a 23.7 to 23.7. Basically the absolute value is going to get rid of the negative sign. Remember those absolute values that you did in math? So that's what it is doing. Now I'm sure you remember all your trigonometric functions, right? Cos and sine and all that stuff. So that's basically what it's doing. So cos, trigonometric cosine of x, 0.0 is 1. Similarly, if you go, so these are some other methods. So these are the ones which takes two parameters, x and y. So it tells you, describes what it does. It says larger value of x and y, smaller value of x and y. So this is where it kind of describes what these methods are. So ceiling is round x to the smallest integer. Cosine, this is what it says, what it does. Exponential method. If you sometimes see power, okay, square root of, okay, tangent. So these are different kinds of methods. All right, let's take a look at some examples. And again, what I'm going to do is, I already brought some of these book examples. We're going to run it in, or put it in our IDE and run it and go over those examples. So we said we're going to start our, what happened to my NetBeans? So here is my NetBeans, and I did not do anything with the filter. So my project name, and I'm going to name it as chapter 6 method example. So this is my project, and I would not want to create a main class, and I'm going to finish. So this is what it would do. And now I'm going to go back to my E drive. Okay, so let's take a look at some of the math test. So I'm going to call this, so I'm going to come to my chapter 6 method examples, and if I click on my source package, there is no source here at this point yet. So I'm going to select my source package, right click, new, and create a class, and this is going to be called the math class. So math test, sorry. That's okay, whatever. Okay, we'll finish it and then come in over here. And I also want to make sure that you all know what I'm doing, because unless I have the right class name, I cannot compile it. So that's why I'm looking up the class name, but since I'm not creating the main method, I'm leaving out the two body curly braces out. So I'm just copying in just the main method. So these are some of the examples of all these main method, and as you can see, most of these things are hard coded. Okay, so there is no interactivity to it. It's just showing you that some of these are the math methods. So I'm going to come to run my file, and then I can compile math test. Okay, and this is my output. Now remember, in our case, we have the output coming in a new window because it was too much to put everything in one place. So here is my output. So this is my math class, and this is what my output is. Now let's go back and add another one. So what I'm going to do is, let me go back. This is called sphere. Now before I move out of this one, is there any question? This is very, very simple. System out print line, and they're just calling the class. Remember, it is out of the class math dot, and then it's calling the method and then passing the value. Okay, so that's basically what it's doing, and then system out print line is basically giving you the value. So if you look at the output, it says the absolute value of 23.7 is this, absolute value of 0.0 is this. Now let me also point out one thing over here. You see all these zeros that you see over here? Why do you think that's happening? Right. If you go back and look at the printf, okay, look at how I'm doing this printf, okay, and I'm not specifying anything over here. Okay, so if I want to make it only 2-digit, then I have to do that 0.2. So 10.2 or 5.2, that would be 2 decimal that I can specify right there. Everybody good? All right. So now I want to do this sphere. Okay, so what I'm going to do is I'm going to come to my source package again, right click, go to new, create my class, and I'm going to call it sphere. Okay, finish, and then come over here and here is my method. Now let's take a look at my method. Now of course, as soon as I start this, it's going to give me an error right here. It says I don't understand what you mean by scanner, and that's where I have to import my scanner, and that does it. So we are good at this point. So now I have my public class sphere, and then I have my main method. So this is another example of a main method, and it is static. Okay, so public static void main. Now again, what does this static means? Again, if I want to run my main method, I can run it with just the name of the class. Remember what we said earlier? So static is I can run that method by just calling in the name of the method, and then that should run it. Now I do have a scanner input, which is my input is my object out of the scanner class, and then I write my statement system out print, enter the radius of this sphere. Now this is how I'm making this interactive, so it's not hard coded anymore, right? So now it says double radius input dot next double. Again, there should not be any question here. You have seen too many of these things before. And then I would come in and say system out print f volume is this sphere volume radius. Okay, now this is a method, right? And how do you know it's a method? Because it has the opening and closing braces right afterwards. Does it take a parameter? Yes, it does. How many? 1. Okay, now what kind of parameter does it take? It says radius, right? What kind of value is this? Double, because I defined that earlier as radius. Okay, now at this point the program does not know what sphere volume is unless you have written your own method. Okay, this is an example of the method that you are writing on your own. You can write your own method. If you don't like any of the library ones, you say, I want to write my method, absolutely okay. So this is where I say public static, okay, double sphere volume, double radius. So this is my setup of my method. So this is my signature. Okay, so once I say it's static, it means if I want to use this method, I can just call it anywhere in this method just by the name of the method. So in this class, okay, if I want to call this method, I can call it multiple times. So what if see what I'm doing? I'm just adding another one, calling it 2, okay, and then I'm going to write another statement here, and just pass in my second one. Okay, now can I not have done it a little differently? What if I wanted to call it twice, I could easily put them in a for loop, right? Or a while loop. I said while my counter is 1, I initialize my counter, less than 3, I'm going to ask this question, display the value. Again, it's going to go back, ask my question, display the value. Okay, so I can do it that way as well, right? Questions? We're good? All right. So now what I do is, if I now run my program, so I'm going to run my file. It says enter the radius of the sphere, and I say 2.8, and it didn't do anything. So volume is, the first one is 91.952323, and the second one is 229.847296. Okay, now I forgot that I added my second line. So enter the radius of the sphere, asking me twice. Okay, 2.8, 3.8. Now I forgot that I did not write this enter the radius, the system out before. So it's looking for 2 values. Now if I come back and look at this, you see how I did not need to write my method twice. I wrote it once and I called it twice and it did it for me. So this is what they're referring to as reusing. Okay, I don't have to write it again. Now, could I not have written something like this? So now I could again go back, run, file, and then my compile. So, well, I'd never used it. So I have to come in over here and maybe call this method call right. So it's my welcome method. Now let's run it. So now it says, welcome to my Java program. Let us begin. Enter the radius of the sphere. So I put in 5 and then 2.8, and the volume is this. Now I put 5, right? But I thought we said that it is going to be a double value, but it still took it. Why did it take it? Because it changed it from a 5 to a 5.0, right? So Java IDE is smart enough to let you convert some of these values even if it does not match the signature. Okay. However, they try not to do it the other way around. So what they're saying here is 5 and 5.0, there is not going to be any loss whatsoever, right? Because if you say 5, then 5.0, no loss. However, if you say 5.7 and try to force it into an integer, then you're going to lose that 0.7. So if you want to be very precise with my calculation, I'm going to get an error in the calculation. So Java would give you an error saying, hey, you are trying to do something. Now sometimes it would just ignore that and change that 5.7 to 5 and do the calculation. That's where you have to be careful when you are using some of these values where you have a potential of a loss. Now, does Java not allow you to convert between values? Yes, it does. The process is called casting. So if you now want to take a double and actually force it to be an integer, you can cast it and say, okay, 5.7, I'm going to change it to an integer, and then I'm going to lose my 5.7. Okay, so you can do the casting, and also you can change some of these things into strings. All right, Java would also allow you, there's a method called toStrings, which makes everything, even the values, change into a string variable. So then it is automatically a string variable. So we can change our data types in between when we call our methods. All right, so any question here in this sphere method? No problem. Again, it's a static method. Okay, that's why I can call it anywhere in this program. Okay, that makes it easy. I can call it anywhere. Okay, let's take a look at the maximum finder program. Again, it's coming from the book. So I'm going to open this one, and I'm going to copy so I'm going to come to my source package again. Remember, I'm still within my chapter 6 method example project. Okay, so I'm going to come to my source package, right click, go to new Java class, and we called it maximum, what was it, finder. Okay, all right. Of course, it's going to complain about this, import, so we should be good now. So let's take a look at this class. I start off with my class called maximum finder, and then I have my main method. Now, let me also stop here and point out something really quick. Remember when we said earlier that all classes have one main program, right? Now we are still sticking true with that. So it's all programs that has the main, does have main, right? One main program. And this is actually a tricky question in one of the Java exam test. They say, what if you have two main programs in your class? Can you do it? The answer is actually yes, because what really matters is you have to specify which class you're calling it. So over here, you see you have your math test, maximum, finder, sphere. Individually, they have their main methods, okay? But I'm still running it because every time I run it, I'm actually running the file. So it is associated with maximum finder, okay? So that's the main method that they are running. So if you sometimes write something which has two, as long as you have the first one associated with that right class name, it should be okay. Then in turn it might call the next one, okay? But again, let's keep that out. I just wanted to point that one out because remember how initially the other day we were trying to run our files in NetBeans and we could not do it. And what I found out was, if I try to click over here, this is my run project. This is actually trying to run that entire project from the top. So if I only had one main, it was okay because it knew exactly which main class I'm referring to. But when I have multiple classes like this, now it does not know. So if I want to run it from here, it does not populate because it's still saying trying to run my project as method examples, okay? However, when I go to my run and select running my file, which is this file that I have chosen, now it creates that file for me, okay? So if I come to my run my file, so now I said enter 3 floating point values separated by spaces. So let's input the values 57.8 space 58.9 space 41.9. Oops. 57.7 space 85. 57.8 space 7.89. So here is my maximum value. So let's take a look at the maximum finder example. So start with my input. I have my system out print line, double number 1, number 2, and number. So this is where you enter the 3 floating point values separated by spaces. Okay. So take in next double, store it in number 1, next double in number 2, next double number 3. Now double result, and then I call this method called maximum and pass 3 parameters or arguments. Both of them are used interchangeably. And then it says system out print line maximum is the result. So whatever I'm getting out of this method call called maximum is now stored in result, and then I'm displaying my result. Now this is the format that I personally like. Remember how sometimes you can write your system out print line and call your method directly? You can do that, but I kind of like this format where you basically write it out, store it in a value, and that's the value that you're displaying. Let's now look at the method that they're writing. So public static double maximum. So everybody good with public? Static, which means I don't need to create a new object to call this. So I can call this maximum multiple times in that class and it should run no problem. All right. So then I have three parameters, double, 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 x, y, z. I assign an variable called maximum value and actually take the very first one that comes in and assign it to be our maximum value. And then here is the condition that I run. And again, this kind of sort you guys have done a lot in your 1000, right? So what you're saying is this value that you are getting for the second one, you're comparing it with the x value, the first value. Now I just set it up as my first one as my maximum. So once I compare, okay, if y is greater than the maximum value, then I'll change the value. So I would set my y to be the maximum value, right? Initially it was my x, right? And then I do another one. I said, okay, now if z, I'll take this one, is greater than the maximum value. Now remember, if initially my value was set with x as the maximum, if the condition was true, my y value is now my maximum. So I'm comparing my z with my maximum value. And again, if this is true, then I would use the maximum value for the value of z. So I'm checking and making sure. Now, if it is not, okay, then I don't change it. So let's take a simple example, 7, 8, and 9. So I set up my 7 as my maximum, right? So I say, is y, remember this is 8, is 8 greater than 7? Yes. Then I'm going to take my value of 8 and store it in my maximum. Then I come back to the next line, z. Remember, this was 9. Is 9 greater than what? 8? Yes. And then I set my z value. Now I can change it with any number, 5, 3, 9. So that's my 5 set up as x, 3. Is that true? No, I'm not going to set my maximum value, so I leave it at my x. Then I go to this 9, 9 greater than my maximum value, which was 5. Yes, I set up my maximum value, and then I just display my maximum value. And then I return my maximum value. Now that's also something very, very important. Since you say double, you have to return something, otherwise it's going to be an error. Okay, so the value that you actually get out of calling this is now stored in result. Problem. Everybody good? Okay, now what if I want to display a nice welcome message? I have to rewrite my welcome message, right? Or I can do something like this. Is it an E? Yeah. Is it going to work? Why not? Correct. What do I do to make it work? Yes, thank you very much. So if it is a static method and it is not in the same class, now where was it? Was it in Sphere that I wrote? So I'm going to say all right. So now let's run it. Welcome to my Java program. Let us begin. Enter the 3 floating point values separated by spaces. Okay? All right. Now, remember this one over here? We also had, look at this. So there is a value, there is a library function that is already there. I can use that one as well, right? So if I come to this one and I say, you know, I don't want to write all this thing. I'm going to say make sense? So I say using my library method, my maximum is, and I call my math.max number 1 and number 2. I now try to go this. No, I'm going to run my file. So works. All right. Everything looking good so far? Yes.
So when using the math.max class and the math library, I noticed that you only put 2 numbers.
Great question. See, I was expecting that somebody's going to catch that. So remember my max method, the library method takes in 2. So this is where or why some people said, you know, I don't want to use my library method because it only allows me to do 2 things. So I write my own. Okay. Or the other thing that you can do is this. Remember what we said about method can call other methods? So I'm going to do how do you like that? So then I call my math max, that's my number 1, and I put my separator, and then I call the second one. Yes? So I trick my system. So run file, but very good question. So here we go. Working? I can do the same thing with my min, right? So, and another thing I want to point out is 58.7, 25.9, 54.9. So remember how it took in the space? It said use a space. It also would take the enter. Now what if I want to end? That's where I have to do that Control Z. That's when it knows, okay, it's the end of my input value. But if you just do enter, it still thinks, okay, you're still putting something in. So either a space or an enter would be okay. All right. So let's look at a few more examples, and we are still looking into some of the book examples, and then I'm going to show some of the outside examples. So I'm going to come back to my 6.3. This is my random integers.java. So let's take a look into this one. So go back to my source package, create a new class, and what is it called? Random. Okay. Now, just like your scanner, what I'm doing over here is creating an object called random numbers, okay, which is of the type, this is my class, secure random. So of course it says it does not understand it. So if I do my import, then it brings it in. Now, you see what I brought in java.security.secureRandom? This is how you can use the Java method in a secured format. There is also another class called just random. Okay, so the secure random gives you a better protection, whereas the random would still give you random numbers. So both of this would do the same thing. So just like I brought that security package, there's a lot of other packages that the Java has. It has packages for drivers, it has packages for network, it has packages for security. Okay, that's why we call this thing a very, very rich library language. So if you just bring in those packages, then you can actually associate, or you can create objects out of these classes that are already included in those packages. Okay, so this is why when we create those structures, those import statements are important. Now also, since we have already covered the class and object, these two should also be pretty clear now. This is my class and this is my object that I made out of it, and everything would always go with a new and the class name. And remember what this is? This is my constructor. So if I open up my secure random, there is probably a constructor, a default constructor which does not take any parameter. Now they could also have another one inside, I do not know, I'm just saying, which might accept multiple arguments. And in that case, when you say secure random numbers equals new, you just pass in those values. With me? All right. So this one creates this random numbers. Then I have a for statement with counter 1, counter less than equals 20, counter plus plus. So let's run some of these things. So I say int face, this is my variable, equals 1 plus random numbers dot next int, and then it passes a value over here. Okay, now let's go back to this, and we have quite a few things that we talked about, you know, the static methods, return values. Okay, We also looked or talked about some of the stack frames. I just did not use the term. Remember that boss module that I was showing you? What it's telling you is you can have one method call another method, okay, and in turn call another method, and that is another example that I showed you in that math max. So I had one, since it takes two, I did one, I call another method, I will take the output out of that one and then call my second one. So every method that you call, okay, you have one class and it has a method, and as soon as you execute that method, it knows who called you. Okay, now this method in turn, if it needs to call somebody else, okay, then it passes the control to this inside method. This method now knows that my outside method is the one that called me. So as soon as I get done, I'm going to give the control back to my outside method. Once my outside method gets done, then it's going to give the control back to the method that called me. So that's how it runs, and in programming terms, we call them method call stack. Okay, so we say when we have methods like this, every method that gets called knows the address of who called you. Okay, so as we get deeper and deeper and deeper, we push it, and the analogy that everybody uses is this stack of plates. So you have one plate and you push it down, you push another one down, so it keeps on going down like this. So it's going, the methods is going like this. But when it starts coming out, it comes out from the top. Okay, because it passes all those things, because every single one would remember who called you. So as soon as that gets done, the control gets back to that one. That gets done, the control gets back to the outer one. So it will move on like this. So that's basically what it's talking about here. Okay. This is also something that we talked about a little earlier, where we said, remember the example that I was giving? It said it's going to take a double value, but I passed an integer, but it still took it. So that's what it's referring to. When you do not have a loss, then the IDE would accept it. So it's giving you, you know how the longs and floats and doubles are different? So it says, if you follow that example, the rule says, for example, an int can be promoted to the higher types, long, float, or double, because there's going to be no loss. Okay, but when you try to do it the other way, then you have to do it with a cast operator, and then it tells you the promotions that it would allow. So again, as I said, double, float, it could be double. Long, it could be float or double, because if you go back to the very first chapter, it tells you what a long value is. It gives you that range. Okay, so the other one is a little higher up, so that's why it still is okay. So this is basically the chart that it follows, and again, this is only going to be important if you want to do programs with very, very precise calculations. Okay, for our purposes, it's probably okay. Now, the reason I came back to this, remember we were talking about this secure random and random. So when we have packages like this, why is it that you would use secure random versus random? Because when you call secure random, that secure package, it does take a lot of processing power. So if you have too many of those secure random, then it might slow the process down. So if you know that some of these things does not need to be secure random, then I would rather stick with my random number. Okay, So talked about this one, and then we also kind of talked about some of the packages. Now in our case, we haven't quite used the event and the geometry, and we did use the IO, remember system.in, okay, so we did use that, but most of these things are kind of included. You do not have to write that import class at the top, but there are other ones like net, security, Java SQL. This is something that I hope that we would get to at the very end, where we would write a database and try to connect with our Java program. Okay, utility, so there are swing. Okay, we would use the fx. Okay, when we get into, we have already started looking into some of the GUI application that are using the fxml, so we need to include that package there at the top. Okay, so these are some of the packages that you see. So let's come back over here, and this is where I kind of try to explain why is it that we are using random numbers. And also wanted to show you something, which is okay, see this section right here which calls about the scaling factor and scaling. This is what these numbers would mean. So this is the part that you need to go back. So basically what it says is, when I have a number like this, this actually tells you that my range is going to be from 1 through 6. And if I say I have a 1, this is my shifting value, it tells me that I want to start from 1. So I don't want to use 0. I would want to start from 1, and the value should be something between 1 and 6. So if I want to generate 2 values, then I would not do the 6, I would only say 2. Okay, so this is where you're talking about a shifting value, in this case 1, and then the scaling as to how many you want to generate. All right, so in this case I want to generate 6 numbers, but I could only need 3, and then I would change that to 3. So the first value is your shifting value, and then you have the face. So this is my 1, 6, and then I have a system out print line, and I would print my face. So let's take a look at my program here. So this one starts with 1 less than 20, yes. I'm going to come inside int face, so I'm going to have a value in face 1 plus random numbers dot next int 6. So this random numbers is going to generate a value, right? That's the whole purpose of random number. It's going to generate a value between 1 and 6, and if you run it 100 times, it would probably generate some kind of a different number. Okay, so and then it's going to be stored in face system out print, and I'm going to print the face value. Okay, now I'm still inside my body here, so I'm going to go to my next line, line number 27. It says if counter, what is this? Modulus. Okay, yes, oh, that's what you said. All right, so counter, so basically I'm looking for the remainder, right? So counter modulus 5 equals 0, system out print line. So basically if I encounter this, I'm going to do a system out print line. So it's going to be a take it to the next line. Okay, so of course that's my 1 less than 20. I'm going to print something 2, 3, 4. As soon as I have 5, okay, then at this point it says 5 modulus 5 equals 0. I'm going to have a print line. So basically I would have 1, 2, 3, 4, 5, and then I'm going to move back. 1, 2, 3, 4, 5. I'm going to come back. All right, so let's run this, and I say 4, 1, 5, 2, 6. So after my 5, the counter 5, I have a system out print line, and that makes me come down to the next line again, 5 of these things. But if you see, there are altogether 20 numbers. Yes? All right. And I'm not going to go through every single one, just wanted to see. So this is where they basically did a frequency. So they're trying to develop a game where they're saying, you know, this is the total number of times it's going to go through. So it is what, 3, 6, 60 million times, right? So int face equals 1 plus random int 6. So they are going to try to count how many times there's going to be 1, how many times there's going to be 2, how many times there's going to be 3, and it's going to do that many iteration. Right? So case 1, so every time I would have 1, I would add to my frequency 1. Every time I would have a 2, I would add to this. See what it's doing? Let's run this program really quick. Go to my source package, right click, new Java class. What was it? Roll die. Finish. Okay. Now, what if I would need to generate more than 6 numbers? Can I do that? Absolutely. Only thing I need to change is this, right? And of course, if I do change this, then I have to come in and declare a frequency counter as well if I want to count. So if I now run it, says it's so this is going to take just a little bit, and this is all. Did I use secure random or random? Secure random. So my frequency of 1 is this many times, my 2 is this many times, 3, 4, 5, and 6. Now, even though this probably would not make a difference, but what if you do I hope they did not deprecate the. See, now I don't need a secure random, it's a random. Okay, so run file. So it does make sense, right? So it does take a little more resource to do a secure random versus the regular one. Okay, questions so far? This may be kind of a repeat. Yeah, switch off, you know, you guys have done this. So let's take a look at okay, this is my insurance program. So now one thing I also want to point out is source package, new Java class, we called it insurance, finish. Okay, one thing I want to point out is, see how you are writing your own method. Okay, this needs to be within the class. Okay, so if you if you miss out on one of these things, you're probably going to get an error there. So make sure that is there. So again, since it's a static method, I can call it any place. So again, making this thing interactive, I declared some variables. My input object takes some value, store it in my current year, birth year, and then this is my method, because this is my calculation of how I'm actually creating my insurance code. Now, addition factor of 15, multiplication factor of 20, age is this, you find the decade, age divided by 10, and then the premium would be your addition factor plus decade times the multiplication factor. Now, how do you know this? The math generally is either given by the person who is giving you the program, or if it's a simple math, they kind of expect you to know. But this is where I tell people that when you are a programmer, okay, there are people who come out of programs where they are very theoretical, right? So you can write programs where you can use a lot of math to do a lot of proofs of certain things using a program. But at the same time, you can be a programmer who's more of a business or an application programmer, where somebody says, hey, I want you to write a program where this is the calculation that I want you to do. So if they give you that calculation, it's now a matter of you taking that value and change it into variables and writing a program that is going to run that calculation. So there are really two kinds of people, and in most cases you will see that there are a lot of people who are just this. I mean, they might not be the ones that are coming up with these factors. So this has actually been determined by somebody, and then you just put that into your application. So here is my insurance program. So basically I define some of the rules here, and this is how I create my premium. Any question here? We're good? All right. Let me bring in now all these things that you saw, these are individual classes by itself. Now I showed you that if I want to write or bring my welcome program over here, I can do that by giving my class name and doing this. Okay, so let's go back and just show you one of the non-static method example, and I saved it for the last because you guys have already seen quite a few of those things. So if I go to this event program and event demo, come to my source package, new class, let me call it event. Everything is looking good, and then I come back over here. All right, so here is a class, and you have seen this before, where I have my class called event and something that you had not seen before, public final static double. What does that mean? It is telling me that it is an static variable and it's final, so it is more like a constant. Okay, so you have a final static double and you also have a final static int. So you have a default value of guest price is $35, okay, and your static event, a large event, is defined as 50. Okay, so if your event is more than 50, those are the two constant values that I'm going to use. And then I define several of these instance variables. Okay, instance variables. They're not the static variables. Okay, now when I have instance variables like this, then whenever I create my object out of my event, okay, they basically share the same copy of this. Okay, so you define them once. Then I have my event. Remember, this is my constructor, and if I do not pass any value, I do have a second constructor here as well. So then if I don't pass any argument, this is my value that I get, but then I also have a public event. So this is my overloaded constructor. In this case, I would take two arguments. One would be a string number and an int guest. Why do I use a string? Because I probably would not do any calculation on this one. I can still use it, but if I had to do any kind of a calculation, then I would probably not define that as a string. Now, remember what I said earlier? Java would allow you to change something from an integer to a string. So it gives you every possible way of changing, doing things with your program, you know, in this IDE. So when you create your second constructor, it takes two parameters. The first one is a num, and I'm setting it up as set event number num. Okay, remember my event number I defined as a string. Okay, that is why I had to define this as a string. So even if I put 50, okay, it's converting it to string and then storing it, and then the guest that I'm putting in is setting it with my guest. So right now in my constructor, it's actually calling two methods which are actually written underneath. Remember those stack things that I was talking about a little earlier? So now I have my public void set event number. Now remember, this is not a static method. It's still a method, right? But it is not a static method. So public void set event number, and I pass in the string num, and then I say num equals event number. Same thing, set get. So these are nothing but my set get methods that I'm creating for these three instance variables. Remember how we choose? It allows you to choose everything. So that's what I did. And then, so none of these things are static methods. Okay? And of course, the get event is going to return. The set one is not going to return. Now, let's go to the event demo. This is where now I have a mix of things. I have public class event demo, a main method. I also have a string called event number, an integer called guest, but this is where I'm creating my first object out of my event. Okay, E1 equals new event. So what would be my value in E1? Remember, anybody? Remember that A 0, 0, 0 and 0. So when I declare this E1 with no arguments, that's the signature that I'm going to use. So it has A 0, 0, 0 and then a value of 0. Now then I say event num equals get event num. Okay, so this is my event num. So I would say get event num, and this is where I'm going to store it. Again, my guest, get guest. Where am I getting all this? Get event num, get guests. Okay, now what I'm also showing you here is that I need to create an object, and this is my second object. Okay, event num and guest. Now I call in this method called display details. Now this method is not in my class table. This is actually over here. You see this? Now these are my static methods. Okay, so when I said public static string get event num, see, I don't need to associate that with an object. Guys with me? So since I have defined this as a static, I can count my event num and store it over here. But if I had to use one of the methods from the other one, which is my event, I have to associate that with e1 dot the method name. All right, so when I try to, and then what I do is get event number, I write my static method, input, enter my event number, input next line, and I return my num. So every time I call this get event number, it actually returns a num, but it is a string. And then every time I call my get guest, again same thing, scanner in as the number of guests. This time I'm taking as an int, but then input next line guest. So then I say a display event e. Now this is where I pass in my object. So once I write this one thing, every time I call this display details, I'll have to change my object that I'm passing, right? So every time I create something, it automatically takes it from this object. You guys with me? So this is a combination of your static versus non-static, where I am using my E1. Okay, so let's run this program. Enter the event number, and I say 20, since it's a string, A8547. Oops. A8547. Enter the number of guests. I say 25. Event number, remember the first one where I did not have any value, so that's my A100. The price for an event is 35, per guest is 0.0. Whether this is a large event is false because it's 25. And for the second one, which is 8547, 35, they calculated a price. Because remember, this one by default is at 0. So now I have a price of 875. All right, now if I ask you to come in and add more objects to it, can you do it? So just like you have your E2, you can do E3, E4, right? And then you can also bring in, now this one doesn't have a welcome message. If you want to bring in a welcome message, I can bring in a method that I have written over there. So ultimately what I'm getting to is, you can take the methods that you have written in your several other programs and put it together to build some kind of a menu, right?